Hello, everyone. You can hear me, right? Perfect. I'm super happy I'm super happy to be here with you. My name is Elizabeth Fuentes. I am developer advocate focused on generative AI. And here together with Rosana Suarez, a woman that I really admire because she is amazing. Really, she is an amazing woman who has a passion to deliver and create free content about DevOps. So everyone who wants to grow professionally, it can do it. Can do it because Rosana, she creates the content because she wants to break the barriers that we have in Spanish language. So thank you, Rosana, for inviting me to deliver this talk with you. I'm super happy to be here. So in this talk, we will talk about this new type of observability that we can create using generative AI. Because today, it's not only about to create speed, to create code with speed. We need to create systems capable to predict and prevent failures before they impact our users. Now let's start. Our agenda for today is first, we will talk about the limits of traditional observability. Second, we will talk about AI-powered observability in CI/CD because, come on, who doesn't love to automating away the pain? Because we are going to focus in GitHub Actions. And third, Rosana, we will show you an agentic application to observe. And finally, we will talk about the impact, the real impact, the lesson learned, and the futures. So let's start it. You will start with this phrase here, everything fails all the time, for our CTO, Werner Boges. And this phrase is true, it's super true, because everything fails, and it's not if something will fail, it's when and how fast we detect and respond. Because the key here is anticipation. We need the anticipation because we don't want a problem. Now, the limits of traditional observability. Yeah, we have some limits there, but it's okay. Some solution that we use for resolve these limits. The limits are, we have a reactive and no proactive system because we need the detection first. What happens when you have this observability dashboard and it alerts you 2 minutes after our users are getting complaints in social media? Nothing good, right? We have some noise overlap. Sometimes a lot alerts in 5 minutes, and come on, 90% of that alert probably are noise. We have a lot of noise, and we need to figure out what alert is the first that we need to resolve. We have silent signals. We have a lot of dashboard with different tools, but zero correlation between the dashboard. A slow decision making. When we have a problem, we need to keep the solution. We do debating, we have the war rooms, and sometimes we spend a lot of time in that, and meanwhile our customers are there with problems. And traditional observability is proactive firefighting, noise proactive. Now, let's talk about the impact, the real impact of this problem. And it's not just about money, because we have some another problems. Yeah, the first one is about money, because sometimes when we have an enterprise, the money is the first. And when we talk about money, there is some studies that say that the downtime cost is between about $50,000 or $500 per hour. So you have a revenue impact of that cost per hour. It's not only money too, because when you have this downtime, you lost the trust of your customer too. And then we have alert fatigue. About 70% of our DevOps engineers, they have alert fatigue. And what happens when they have this problem? We have some engineers with burning out. And of course, we spend a lot of time doing troubleshooting. We do a lot of troubleshooting. At this time, it's about 40%. So, when we spend all this time doing troubleshooting, we don't spend this time building innovation, building new stuff for our application. So we lost that time doing troubleshooting. And this is the gap that this application helps us to resolve. We have a lot of data. Yeah, we have logs, metrics, trace, everywhere. Data for everywhere. We are drawing now in telemetry data. Then we have noise and silos. I already told you. We have a lot of dashboards everywhere, a lot of tools, and no correlation between them. We have slow human decision. Slack war room, 40 minutes debated what we do rollback, what we have to do. Meanwhile, our customers are there. And finally, we have the business impact. The customer check it down and trust loss. And the question is, so how do we move from reactive chaos to proactive intelligence? Now, Rosanna is going to tell us a sad history, but with a happy ending.
Rocks. Rocks is powered and unfired. The history we have been there, right? Rocks is Friday night, 11 p.m. Someone jet the magic words. It's quite a small change. The minulator chaos, that's on fire, alert everywhere, and someone jet who touch production. Sound familiar? Yeah, really. It's funny because it's true, right? We need intelligence before. The deploy, no after. Traditional wait, deployed, break, alert, fear, too late. AI waits, prevents on time. This is proactive intelligence. This is AI-powered observability. So now, let's dive into the solution. Let's talk about AI-powered observability in CI/CD, specifically using GitHub Actions. There are 4 key reasons why this matters. First, early detections. AI catch read before productions. Second, safety gates. Risky deployments, I love, block automatically. Third, faster recoveries, less downtime, more shipping, and finally, better developer experience. Feedback happens right in the pilot, prevent, protect, and accelerate. So, what does this mean in real number? Easy. From 200 alerts per deploy down to just 5 alerts, that's really matter. NTTR from 2 hours. Why? AI. 50 minutes, 8 times faster. That saves a lot of money. Every single time, AI prevents those incidents, less noise, more insight, zero surprise. These are real results from productions, isn't AI-driven observability. So, how does this work inside GitHub Action? Simple. The moment you push code or create pull request or any deployed step, AI starts analyzing immediately. It collects metrics, logs, a pod, even from Kubernetes. It checks everything using some Amazon Bedrock, beautiful, Cloud, or OpenAI. It decides, amazing, block, alert, warn, and send telegrams, alert instantly. That's it. 3 critical moments. The first moment is the pull request. Here, AI gives advice and shows risks before we merge. It's only advice, no blocking. Just a small automation improve the pull request better. This is the second moment, and it's very important. Pre-deploy here, the AI can approve or block deployment. If the system look, but the AI stop the deployed, this protect production. The third moment is post-deployed. After we deployed, the AI check everything again. It send a report, an alert if something is wrong. These three moments make deployment safer, faster, and easier for the teams. When the pilot starts, the AI checks everything, the code and the environment. In the pull request, AI write the comment on GitHub. Is everything okay? It say, AI pass deployment approved. If something is wrong, the AI stop the deploy and send a notification to Telegram or any tool about select. So developer can see the result in GitHub and teams get the alert in real time. And the deploy is approved, the AI run the deployment, build and test, security, deploy, and optional post-deployment validation to check if the app is healthy. This makes the process smarter and safer if observability comes to you. Let me show you how this works in real life. Developer push code, file and start. Beautiful. AI check the system take maybe 10 or 20 seconds. If everything is healthy, green light, beautiful date. Problems, red light, block, TeamSpeak and Telegram message immediately. That's it. Simple, automatic and safe, no manual approach. Right now, Elizabeth showed our solution.
This application works initially with 3 model providers. We have the Amazon Bedrock model provider, we have Cloud, and we have OpenAI. But because this is an open source solution, you can change, you can do a little change in the code, and you can put your favorite model provider there. It's a simple solution that you can change because this solution is using a Strands agent, and a Strands agent is an open source framework capable to manage capable to resolve the question and all that using an agentic loop. And using the agentic loop, Strands agents deliver the answers. So the Strands agent is the brain for this solution. And here we have the OpenAI and Amazon Bedrock and Cloud model providers. And because, again, this is an open source solution, you can switch a Strands agent with another framework that you want to use. And then we have the Kubernetes. Inside the Kubernetes, we have the Prometheus and Grafana. And this application, they capture all the metrics. They can see, they capture the CPU, the memory, the restart. They see everything, so they can share this information with our Strands agent inside there. And then we have 2 important things in this solution. We have 2 gates. The first gate is, I can see anything there. With the first gate is the pre-deployment health check, because every time we put a code there, the agent see everything before this code goes to production. And if the agent doesn't approve the health check, the agent is going to block the deployment. And the second gate is the post-deployment validation. In this gate, the agent validates everything went well. And finally, the agent, this application sends a Telegram notification with all the progress the agent do, all the information, all the things the agent capture for this deployment. And everything is triggered by GitHub. So every time you do a push, this flow is going to Gate. And let's talk about the flow that this application is using. We have a decision flow just here. First, we have all the data. When we pull metrics from the Kubernetes, the pod status, CPU, everything is there. We send this data to the AI agent. And this agent generates a health score from 0 to 100. And this is no magic. You know, we have a prompt that have a specialization like a DevOps to understand everything what is happened there. And then this agent makes a recommendation. If this approved, come on, deploy. If it's más o menos, en español, is so, we deploy with warnings. But if it's not okay, if the agent stop everything, so if the deployment is not good, if the recommendation is split, don't deploy. And then it sends the notification by Telegram. And this is the prompt. This prompt is they use some pattern recognition. Here we have the agent is not only about CPU. The agent use the CPU, the restart, the error logs. The agent tries to use everything to give you this recommendation. And you can see there that the agent used to the crash loop backup patterns. It used to the image pool backup. And this are like classic deployment failure that every DevOps engineer knows. But here, you don't have a human here because the agent can catch them before they impact the users. And in the prompt, you can see the score. You have 90. If the agent put the score, if it is 90 to 100, it's excellent. Come on, deploy. If 75, between 75 and 89, good, approve with monitoring. But if the score is 70, between 70 and 74, it's not so good, but approve with warnings and increase monitoring. But if the score is less, that 60 is critical, I recommend you to not deploy. So this is the score that the agent put it there. And now Rosanna is going to show you this application in action.
The most part on the video. Now, let's see this in action. We will show you two demos. First, a local observability. And second, CD pipelines with CI/CD, with GitHub Actions and Amazon Bedrock. Let's start. We have two demos. The first one, a local observability using cloud. Second one is the CI/CD using GitHub Actions and Amazon Bedrock. Both demos using same idea, real-time, fast feedback, and safe deployment. Requirements. What you need before running the demos. First, local environment, your laptop with Docker install, terminal, or access, ability to run local script. Second, configuration files, an environment with AI model providers, selections, cloud, Amazon Bedrock, or OpenAI. Third, the best part for me, Kubernetes environment with local or remote, in this case, AWS EKS cluster. Prometheus runned, yes, and application deployment, example, demo apps or Nginx. And for GitHub report, access the content, and that's it. Everything is documented. Scan the QR to access the repository and start building. Let me show you the repository. Inside the source folder, you have important directory. The first analyzer folder contains Kubernetes and Prometheus logic. Second, the models folders manage different AI providers, Bedrock, Cloud, or OpenAI. The notifications folder sent to Telegram and tools contain the observability script. Everything you need is here, ready to use, simple modular Python, scan QR. Our system supports 3 AI providers, Blood, Bedrock, Cloud, or OpenAI. In our demo, user strums connect everything. Each day is talked the AI provider is managed the agent logic. This makes our system simple, but strong. Let me show you how simple this is. The code shows how we load each provider. If the user select OpenAI, we load OpenAI. If they select Cloud, we load Cloud. And if they select Amazon Bedrock, well, we load Amazon Bedrock. The idea is one code, many AI models. To run the local AI agent, we use this command, python make.py. The agent connects to the cluster, the real-time metrics is calculated on health score from 0 to 100. Then it decides if the system is healthy, risk, or critical. This is a simple way to test the AI locality. This part is important. AI is no magic. It needs good data to make good decisions. Before we continue with the demo, I need to explain something important. Where do the metrics come from? The answer is Prometheus and Grafana. Prometheus is our metrics collection system, and Grafana is our visualization tool. It's queried Prometheus and show the data in beautiful dashboard. This is the standard stat. Many companies use the configuration. This is powerful. We also use Telegram for notification. Telegram is an amazing box system. The AI sends the message, the result approved, warn or block. This is fast and easy for the teams. You can receive alerts in your phone in real time. You can also use other tools, Teams, Slack, WhatsApp. But in this demo, we use Telegram because it's very easy to automate. The first demo shows how local observability works using cloud model. Here, the AI watches the system in real time. It checks the Kubernetes and system is healthy or not. If healthy is good. We say system healthy if something looks wrong. The AI explains the problems and what action we should take. In the repository, we have the script for local execution. With the script, we can test different scenarios. Healthy system, load testing, critical failure, or recovery. The AI reads the logic and the command in real time and show the system status locally, so we get local observability before we deploy anything. This file is a .m configuration file. It shows how set up local environment, which shows the AI provider, in this case, Cloud Model ID and Cloud API key. Then on the Kubernetes settings, like the namespace, app names, and cluster names, with the small files, we can run the daemon locally and get AI observability before deploying. Here, the perfect date, the AI agent run locally using Cloud model. It reads the metrics from Prometheus and check the health of the system. Right now, the system is healthy. We see 100% score, no anomaly, because everything looked good. The AI approved the deployment automatically. Now, this is where the magic starts. We triggered the demo using local script. The AI agent connects to our AWS EKS cluster, the cloud model, and the target namespace. So Prometheus is gathering real-time data, CPU, memory use, active connection, and pod health. With that information, the agent analyzes an AI health score, verifying the system is stable, no restart, no anomaly, and everything running cleanly. Send notification is beautiful, the local script, and once analysis complete, the AI automatically approved the deployment and send detailed telegram, including the model use, system status analysis time, and confidence score. Let's see what happened, things go wrong intentionally. The AI detects the problem, the health score is low, so the AI blocks the deployment. Now we are going to simulate a real failure scenario. We run a local script and boom, only the chaos starts in our EKS cluster. You can see how the main application starts to fade, pod and crashing, restart, and metrics begin to drop fast. At that moment, the AI agent connects to the cloud model, pull live data from Prometheus, and start analyzing everything: CPU, memory, put, events, including the detect error and suggestion remediation step. It's beautiful how running in the script. Analyze Prometheus and set notification to Telegram. Switch to Grafana, every time light up in red, perfect view and controlling chaos, and with the AI we trace exactly what's happening, why, and how to fix it. Finally, I say detail, Telegram notification. Perfect, beautiful day. Demo 2. The second demo add AI to GitHub Actions. Now the AI is part of the pilot. It checks everything, pull requests, and every deployment step. But the important part, the AI observability running behind the scene. This is our AI-driven observability inside GitHub Action. It starts with the AI deployment gate using Amazon Bedrock or any model we choose. Here on the right, you can see the configuration, the cluster name, the namespace, the model provider, Prometheus, and our Telegram bot for notification. With just this parameter, the AI knows where the app is running and how to verify system health. Now, let's see in action how the pilot actually before and after deployment. This is the amazing Dockerfile is built the AI analyzing container. We start with Python 3.13 Alpine. Alpine is very small and fast, a good practice. Then we copy the requirement files. We install the Python packages. We copy the application app. We set the working directories. We create a null root user for security, and we set the entry point script. This container runs in GitHub Action. The entry point script is important. It's run the Python analyzer. Then inject the exit code. If exit code is 0, the deployment is approved. The exit code is 1, the deployment is blocked. If the exit code is 2, there is an error, the Spring client message instead you happen, then it exits with the correct code. To publish the action files, the file defines the inputs. For example, you can choose the AI model provider, you can set the Kubernetes namespace, you can provide the app's name, you can give the cluster name, you can add the Telegram token for notification, and these imports are optional. They have default values if you don't provide them. Now, how does the action run? We use Docker. Docker makes it simple. The image is on GitHub. We send settings to the container. What settings? Your AI shows the cluster information, your Telegram detail, GitHub adds information automatically. The pilot's ID, code version, the environment, everything connects automatically. It's easy and safe. Good news, now the action is public. Developers can add it to their pipeline with just a few lines. The make option simple for any teams. This is how you set the action in your pipeline. In your workflow file, you use rocks/age-driven DevOps automate. This example shows the full step is very simple. You only add one line, the action name, the AI will run during the pipeline and give you a decision. Because it's easy, any developer can use it fast. This is our AI-driven pipeline in GitHub Actions. It starts with the AI gate, check, help, build, deploy, and validation again, automatically on every push. In this demo, we are inside the repository that defines our GitHub Action workflow. It starts with the AI gate job, where we pass parameters like cluster name and model provider. So the AI knows exactly what environment is analyzing. Then we push a new commit and the pipeline runs automatically. If we go to GitHub, we can see each job in action. The AI gate download the action, connect to the cluster, and start analyzing health of the blackjack apps. It's perfect, the runnings, the action. It sends and Telegram notification with all details, environment, commit, model use, and help analyzing the pipeline they continue through to the build, security, and a post deploys. And again, send detail is optional, send again with information. That's how AI automation work together to make CI/CD safer, faster, and easy. This, the AI observability check running and the pull request is analyze, perform, memory, and session, everything pass with perfect health score 100. In the demo, we create and pull requests from feature branch on the deployment branch. And soon, as the PR is created, automatically trigger the AI observability pipelines and full review of the system current state before merge. We can see the agent runs inside the workflow, connect to the cluster, and start is analyzing this where the AI begin is magic and beautiful. And it check the cluster, health, review metrics, event logs, everything from CPU, memory to application session. The result, 100%. No critical events, no warning, everything is green and stable. Once the validation is complete, the AI automatically approves the deployment mark of PR as ready for mesh. This time, the AI observability check critical issues. When the AI detects problems, it blocks the deployment. The pull request shows a red message with detail that prevent failure from production. In the demo, we simulate a fail inside the cluster. Then create pull request to start the validation again. When the workflow starts, the AI agent connect to the cluster and begin analyzing. But this time, things are not okay. The running in the pipeline block and AI find error in the application and problem in the POPs. So the AI block the deployment immediately, is approved and create commit message why the reason for the block and the health score and the main issue is formed. It's also send Telegram notification with the same report and simple recommendation generated by AI observability engine. These are the real-time notifications sent directly to Telegram. On the left, we see successful deployment Amazon background report and perfect health score of 100. And AI confirms system healthy, deploy approved. On the right, critical scenario, the AI detect pod failure, mark and her 68 out of 100 and immediately block the deployment. This kick time, instant visibility, AI decision analyze, and next step delivery right here. They already collaborate. In this case, Telegram notification, but use other tools with Teams, Slack, WhatsApp, Discord. AI in DevOps is already changing how we deliver software. And the future, faster decision, more on time, and teams that ship with confidence. Three takeaways. AI prevents failure, not after, but before. You can choose the AI model, more flexibility, more confidence, clear explanation, build trust. Teams shift faster when they understand why. These three ideas make CI/CD smarter and safer. The future of CI/CD is AI-powered. We don't observe our system anymore. AI protects them, it predicts problems, prevents failure, and keeps every deploy safe automatically. This is the next generation of DevOps. Imagine two companies. Company 1, traditional observability, deployed, wait, something breaks, fix, 3 a.m. calls, stressed teams. Imagine company 2, AI-powered observability, analyze, predict, block, back deployment, approve, good ones, no surprise, happy teams. So, here's the question. Which company do you want to be? Do you want Git firefighting at 3 a.m.? Or do you want AI protecting your deployments? The choice is yours. The technology exists today. The code is open source. The demos are ready to run. You saw everything working right. Now it's your turn. Take the repository, try the demos, transform your teams from reactive to proactive. The future is AI-powered. Start building it today. Let me close with this. AI won't replace engineers, but engineers use it maybe. AI is a tool. It's made you strong. It's made you faster. It's made you better. They can prevent problems. Don't be afraid of AI. Use it, and you will be successful. Here, on the useful resource, you can learn more about the tool we use. You can explore AIs, DevOps, and CI/CD. This link helps you continue the journey. Learning never stops. Want to learn more about building AI agents? Join the course. Scan the QR code to register. This workshop complements everything you learned today. Right now, Elizabeth, comment about this course.
Thank you, because this is an open source talk. This is a completely free course that we deliver. I deliver this course with my colleague, Laura Salina. And this course has 4 courses inside. We have the first course is about starting with trans agents. And because using a trans agent is easy, you can deploy a completely agent to production with a few lines of code. The second one is create advanced agents using MCP. The third one is multi-agent system. And the final course is about put agents into production using Agent Core. And it's completely free, it's there. And thank you so much.